Hi all, welcome to my channel AWS for all. Today we are going to talk about two things. One is security group and other one is network access control list. Both are security features provided by AWS. In this diagram, the public subnet is hosting a Windows server and a Linux server. And Windows server is attached with a security group 1 which allows TCP protocol on port number 3389 to RDP the Windows server. Similarly, the Linux server is attached with the security group 2 which allows traffic on TCP protocol port 22 which allows user to SSH this machine. Security groups are stateful in nature. That means if I open a port or a traffic in inbound, I don't have to open the same traffic for the outbound. By default, the outbound traffic will be allowed. In this example, if I open the traffic for TCP protocol on port 3389, the same outbound traffic is automatically enabled. I don't have to explicitly open outbound. Instant Instance level security. Security groups operate at the instance level. That means each security group can be attached to a separate instance. In this example, security group 1 is attached to the Windows server, security group 2 is attached to the dedicated Linux server. Allow rules only. Security groups will have allow rules only and there is no deny rules. By default, all the rules are denied. If I don't specify any allow rules, all the traffic is blocked and nothing will be allowed to the Windows server or any other server. Multiple security groups. Security groups works at the instance level. However, each Windows server can have multiple security groups. For example, in this one, right now we are attaching security group 1 to Windows server. Along with the security group 1, we also can attach security group 2. If I attach security group 1 and 2, uh, both TCP traffic on port 22 and TCP traffic on 3389 allowed for Windows server. Default security group. Every VPC comes with a default security group which allows all inbound traffic from the instances within the same security group and denies everything else. What it means, if I have a security group attached to two different instances, those two instances traffic are allowed by default. For example, in this case, if I attached a security group 1 to Windows server and security group 1 to Linux server, by default all traffic between Windows server and the Linux server is enabled. Dynamic rule changes. Security groups allows dynamic rule changes. That means when the Windows server is running with a security group attached, if I remove the rules inside the security group, immediately the traffic will be blocked. For example, if I delete the TCP 3389 rule on the security group, the user cannot RDP this Windows server. Similarly, if I remove the TCP port 22 SSH rule in the security group 2, users cannot access Linux server through SSH. It supports both IPv4 and IPv6. Security groups provides a granular control, that means at the IP address level, CIDR blocks and security group IDs. We'll see it in a minute. There is no rule evaluation order. Unlike NACLs, the security group rules are evaluated as a whole set. There is no specific rule order. The table shows the security group defined for the Windows server, and the bottom table shows the security groups defined for Linux server. The Windows security group has an inbound rule which allows RDP type traffic on protocol TCP, port range 3389 and source, that is local network CIDR block. which means all the traffic which is coming through port 3389 on TCP protocol from this source are allowed, and also outbound is also allowed because it's a stateful. However, it also has an outbound rule which allows all the traffic for all the protocol for all the port range from anywhere. Similarly, we do have inbound rule for the Linux security group, which allows SSH type traffic on protocol TCP protocol on port 22, and the source is the local network source. That means any machine on this network which is having the source IP in this range can access this Linux server on using the port 22, that is SSH access. And similarly, outbound is allowed for all traffic, there is no restrictions. We will see this in a demo. If we remove the rules dynamically, uh, no traffics will be allowed. This diagram shows blocking the traffic by removing the inbound rules from the security groups. From the Windows security group, if we remove the inbound RDP traffic, the user cannot RDP to the Windows server. Similarly, if I remove the inbound rule from the security group 2 for the Linux, the user cannot SSH to the Linux server. NACLs are network access control list, which are nothing but the firewalls provided by the AWS, which controls the traffic at the subnet level. NACLs are stateless security layers that controls the traffic at the subnet level in an AWS VPC. Unlike security groups, NACLs consist of inbound and outbound rules. NACLs consist of inbound and outbound rules that counts the traffic entering and leaving the subnet. We have to explicitly allow or deny both inbound and outbound traffic. Supported to this, it has allow and deny rules. Each rule either allows or denies the traffic based on the conditions such as IP range, protocol, and the port. NACLs are stateless, meaning they don't track the state of the traffic, and the responses must be explicitly allowed within the outbound rules. For example, if I'm allowing the port 3389 on the NACL, I should also allow outbound, otherwise outbound on the same 3389 is not allowed by default. NACL rules evaluation in order. Rules are evaluated in a numerical order, that is the rule number. Lower rule numbers will be evaluated first, and it will be processed as the number increases. And as soon as the first matching rule is applied, it will stop the evaluation. Default NACLs allow all the inbound traffic and outbound traffic. In these examples, we are using the default NACL here, which allows all the traffic going to the Windows server and Linux server. However, it's controlled by the security group at the instance level. Implicit deny. If the NACL does not have a matching rule for any traffic, it will be explicit deny. For example, if the user is trying to RDP this machine, the NACL should have a allow inbound rule in the NACL, and also an allow outbound rule in the NACL. If not, user cannot access or user cannot RDP the Windows server. NACL supports IPv4 and IPv6. One NACL per subnet. Every subnet will be attached with one NACL. Like a security group, it's only one NACL per subnet. However, the same NACL can be attached to the two different subnet. Example, the default NACL can be attached to another public subnet in the same VPC. No state tracking. As discussed earlier, the NACLs are stateless, and we have to explicitly define inbound and outbound traffics. The default NACL rules are defined as defined in the table. Inbound rules. There is a rule number 100 which allows all traffic for all protocol, all port range from anywhere, and the status is allow. If I map this our use case, when the user is trying to access the Windows server or RDP the Windows server, first it will hit this NACL and this evaluate this rule number 100, and it says all traffic and all protocol and all port range and anywhere you just allow. That means the the traffic will be allowed and it will go and hit the security group for the next level of evaluation. If I remove this rule number 100, it will evaluate the star rule, and which is the deny all the rules. So automatically the traffic will be blocked at the NACL level. Similarly, the outbound rules it start evaluating at a rule number 100, which is nothing but all traffic, all protocols, and all port ranges for any destinations will be allowed. That means after reaching the Windows server again send the communication back on the 3389. It will start evaluating the rules and it will come here and see this rule number 100, which is nothing but allow all traffic and all protocol and all port range for anywhere, and it will just allow the rules. There is no filter on this traffic. Once it hits the matching traffic, and it will not evaluate any other rules. In this case, once the 100 is allowing the rules, the star is not evaluated. Hope this helps, and we'll see this in actual demo. In this demo, we are going to try 3 use cases. The first use case is demo RDP and SSH rule setup in the security group by adding and removing the rules. Second use case, demo connecting Windows and Linux server each other by adding the same security group. As part of this exercise, the security group 2 I will add it to Windows server also, and connect from Windows server to Linux server, Linux server to Windows server. Demo adding lower rule number to deny access to the subnet in the NACL. In the default NACL, I will add one more rule with a lower rule number to deny the access and test the traffic. As part of this exercise, there are 2 instances which are already running in a same subnet, demo Linux server and demo Windows server. If we go towards the right, and both these machines are running in the same subnet. The subnet ends with 1AA2. They are running in public subnet. Let us go to Windows server. Click on Windows server, go to security, click on security group. It's attached with the one default rule which allows all traffic from itself, the same security group. Outbound rules, all traffic is allowed, there is no filter applied. Similarly, let's go to Linux server security group and check it. In the Linux server, let's go to security group and check the inbound rules. In the inbound rules, there is only one rule which allows all the traffic from the same security group itself. In the outbound rule, there are no restrictions, it allows all the traffic. Currently, both Windows server and the Linux server having one inbound rule which allows the traffic from the same security group. Let's try connecting these machines. I'm trying to SSH the machine from my local machine and hit enter. I have waited for a few seconds and the traffic is not responding. Let's try to RDP to the Windows machine. Click on Windows Server RDP. It will try to connect for some time. It is not able to initiate the connection now because there is no RDP traffic allowed in the security group. Let us change the security groups for both Linux and Windows machines and try it again. Go to the demo Windows server and go to the security sections and click on the security group. Click on the inbound rules and click on edit inbound rules. there is an option to add a rule. Click on add rule and select RDP in the type of traffic and select the port range 73.116.0.0/16 and name this rule as RDP. Click on Save Rules. Similarly, we will go back to the Linux security group and add the SSH rule. Click on Linux server, go to the security section at the bottom, select the security group attached and click on inbound rules, edit inbound rules and add a rule. Click on custom TCP and add SSH traffic. Click on SSH and edit the CIDR block, that is nothing but 73.116.0.0/16 and save the rules. Currently we added RDP rule for Windows security group and SSH rule for Linux security group. Let's try connecting again. I'm trying to SSH the same machine again. I'm able to connect the Linux machine successfully. That means I got the SSH access for my local laptop. ls-la, I should be able to pull it. Let's try the Windows machine. Click on Windows Server RDP. It will pop up with the username at the administrator and password. Provide a decrypted password. Click on Continue. Now we are able to connect to the Windows machine successfully. That means my laptop got RDP connections. The laptop traffic lies within the 73.116.0.0/16. I'm able to successfully connect to this machine. Let us try to connect Windows machine and a Linux machine. That means now I am going to ping the Linux server from the Windows server and the other way around, from Linux server I'll try to ping Windows server and let's see how it goes. Go to the console and select Linux server and you can see the private IP address. Copy the private IP address and go to the Windows session which is already established and ping the IP. Currently we are trying to ping Linux IP from the Windows server. I got a message, request timeout, it's not connecting. Let's disconnect. Let's go to Linux machine and try to ping the Windows IP. Go back to the console and select Windows server and you can see the private IP address. Select the private IP address of the Windows server. Go to the terminal where Linux server is connected through the SSH. Try to ping the Windows machine. I'm not getting any response from the ping. I have waited a few seconds and I'm not getting any response. I'm going to disconnect. Let's fix this issue. So currently, I'm going to attach the Linux security group to Windows server also, so that there is a common security group attached to the Windows server and the Linux server. There is a default rule in the both Windows security group and Linux security group which allows all the traffic from the same security group. With this rule, by attaching the Linux security group to Windows server, it will allow the traffic from Windows to Linux and Linux to Windows. Let's try doing it. Go back to the console, click on Windows server. At the top right corner, click on Actions. There is a security drop down. In that, select Change Security Group. It will, in the search bar, select the Linux machine security group. Click on that and add security group and save it. We added the Linux security group to the Windows machines. Let's try to ping the Linux machine from Windows machine and Windows machine from the Linux machine. I'm on Linux machine. Let me ping the Windows IP. As expected, I'm getting the response from the Windows machines. Let me terminate this connection. We will do the same in the Windows machine. Let me try pinging Linux machine. I started getting the response from the Linux machines. So we successfully established the connectivity between Windows machine and Linux machines by pinging each other. In our demo use cases, we have successfully completed first use cases and second use cases. That means we try to RDP and SSH by setting up the rules in the security group, and we successfully connected. And also we connected Windows and Linux machine each other by adding the same security group. That means we added the Linux security group to the Windows server and hence established the connectivity. Let's try the third use case, demo adding the lower rule number to deny the access to subnet in the NACL. So far we are using the default NACL which allows all the traffic. We are going to add a rule to deny and let's see how it works. Let's go to console. In this console, if we see the Windows server and Linux server both are running in the same subnet as we discussed earlier. This, if we go right, I can see the subnet ID which ends with 1AA2. Let's go to the subnet. If we come down, I can see the subnet and click on the subnet. Click on the subnet ID for getting the details. Right now I'm in the subnet where both Linux and Windows machines are hosted. Come to the bottom of that sections. There is a network ACL which is nothing but NACLs. Click on the NACL. It shows the rule which are defined and also the NACLs actually attached with it. Click on the NACL link. It will take you to the next page where you can edit the rules. Click on this NACL. It will open up in a new window and give an option to edit the inbound rules. Click on edit inbound rules. Add a new rule. I will add a rule number 50 because this should be less than the current rule number. As per the rule, the rule number which is having the low number will be evaluated first. Right now I am adding a rule number 50. All traffic coming from any source is explicitly denied, and I'll save the rule. Currently I have inbound rule which is having the rule number 50, which is explicit deny of any traffic coming from anywhere. I'm in the EC2 machines where we connected through SSH. I'm hitting the enter and I'm not getting any response. That means the session is disconnected. Let me quit and try to reconnect again. I just came out of the session and trying to reconnect. I waited for a few seconds and it's not getting connected. I'm just closing the connection. Let's try the same with the Windows server. Let me try connecting to the Windows server. Click on the Windows server RDP. It's trying to establish the connections. After a few seconds, I got a pop-up message saying that unable to connect. We couldn't connect to the remote PC. That is because the NACL is not allowing any traffic to the subnet. Let us revert our rules by increasing the rule number and see whether we can access these machines. Currently, I am in the NACL portal where we added a rule with the rule number 50, which is an explicit deny. We'll edit this rule number to 150. Click on edit rule number and I'll make the rule number to 150 and save the changes. In this case, the rule number 100 will be evaluated first, and it's an explicit allow for any source, and it's an explicit allow. As soon as it hits this rule, it allows the traffic and it will not evaluate the next rule within the sequence, which is 150. So the net effect is all the traffic should be allowed at the subnet level, and hence a user should be able to connect Windows server through RDP and Linux server through SSH. I'm in same terminal sessions where we tried to connect to Linux machine earlier. I'm going to try again. So I'm able to connect to the Linux machine successfully. Let's try with Windows machine. Click on demo server RDP. I got a pop-up to plug the password. Key in the password and try to connect. I'm able to connect to the Windows machine successfully. So we learned how to block the traffic using the NACL by setting the rules. We successfully completed all three use cases. Thanks for watching. Please subscribe, like and share.